Welcome to this exciting tutorial where we'll build an RGB LED matrix panel using an Arduino. In this video, I'll guide you step by step on how to control multiple LED segments using bitbang SPI communication. We'll explain the code so you can understand how to light up and animate LEDs on a large matrix panel. Let's get started. We're working with a 4x4 matrix of MAX7219 LED driver segments. Each segment controls an 8x8 grid of LEDs, making a total display of 32x32 LEDs. Our Arduino communicates with these segments using SPI signals, clock, CLK, data input, DIN, and chip select, CS. We're bitbanging SPI here, meaning we manually control the timing of signals in software. To manage all the LEDs, we use a frame buffer, basically an array that holds the state, on/off, of every LED in the entire matrix. Each byte represents 8 LEDs in a row, and we have NUM_segments multiplied by 8 rows total. The function shift_all sends commands to all the MAX7219 segments simultaneously. It lowers the CS pin to start transmission. For each segment, it shifts up the register address and the data byte. Then it raises the CS pin to latch the data. This initializes each segment with commands like brightness, scan limit, and turning off test mode. The core animation in the loop uses some math to create moving circles or waves on the LED matrix. We calculate offsets and distances to determine which LEDs to light. The frame buffer is updated dynamically. Then we call show to send the frame buffer data to the LED segments. To control individual LEDs, we use set_pixel, X, Y, mode. X and Y are the coordinates. Mode controls whether to turn on, off, or toggle the pixel. This function calculates the correct byte in the frame buffer and sets or clears the representing the hardware. It loops through each row of the display. For each segment, it sends the data for that row. The function handles the bootstrap-on layout, meaning the direction of data alternates for every other row for the daisy-chained MAX7219 segments. Conclusion. And that's how you build and animate a large RGB LED matrix panel with an Arduino using bitbanged SPI. You can customize the animations and brightness by changing the frame buffer data. Feel free to experiment with the code, add colors if you're using RGB LEDs with more complex drivers, and create amazing visual effects.